Hello viewers, welcome again to our YouTube channel. Here we go again at KQ 2023 projections. Here is a good question for us again today. I will take this opportunity once more to thank you guys for supporting us, walking the talk, sharing knowledge, and standing with us. So at number 15, the question reads, in the figure above, P, Q, R, S are points on the circumference of the circle center O. The points Q, O, S, and T lie on a straight line. PT is a tangent to the circle at point P. We are being asked, find the values of the following angles, stating reasons in each case. So our solution, my rough work will be the diagram itself. So the first task we have is to fill all the angles in the diagram. So some parts were lacking, I've joined them using dotted. My teacher used to say, always join all the parts, because as we do so, so many ideas open up, so many concepts come up, and we shall be able to remember. So the angles given are two. Angle QOR is 120 degrees, and angle OQP is 40. So following down to form 2, angle properties of a circle combined with circle chords and tangents in form 3, we shall be able to fill this diagram. So the first concept I can see here is on this being a diameter, QSO being a diameter, then angles subtended by the diameter on the circumference are always 90 degrees. So there will be a 90 degrees there, and also on the lower side there will be a 90 degrees at P. They are subtended by the diameter on the circumference. So those are 90. So having a 90 down here will imply that this angle, we can get it, because 40 plus 90 is 130 degrees. If we minus it from 180, we get 50 degrees, angle sum of a triangle. Then so far so good. I can see this angle here. Angles in opposite segments, or somebody says angles in alternate segments, are always the same. So the opposite segment is 40. So this angle becomes 40 degrees, and therefore another aspect of the same, angles in opposite segments here becomes 40 degrees. Still, we can get the two 40s by considering chord SP subtending an angle on the circumference. Angles subtended by the same chord on the circumference are always the same. So that aspect can also give us the 40 and the 40. That's why I said we have to join these lines which were missing. Then consider this being a radius. We shall get an isosceles triangle. Radius are the same, so the base angles of the isosceles triangle should also be the same. And having taken 120 degrees out of 180, we are left with 60 degrees, of which we share. That is 30 each. That is going to be 30 degrees each. Then the same concept, now looking at here, angles on a straight line always add up to 180 degrees. Already we have 120, so minusing it from 180, we get 60 degrees. So this being another radius, OP and OQ are radius, and therefore base angles are always the same. So 40 gives me 80 degrees. Minusing it from 180, we get 100 degrees over there. Then angles on a straight line again add up to 180, and therefore 180. If I minus 100, I get 80 degrees. Consider triangle ROP. Triangle ROP, here being a radius and a radius, then it also becomes an isosceles triangle with base angles being the same. And therefore, now that the inner angle here is already 140. Out of 180, we are left with 40 degrees, of which they share to be 20 degrees each. 20 degrees each. So that opens more ways again for us. Considering this small triangle inside here, this is 80 plus 20 is 100. Here becomes 80 degrees. Vertically opposite is another 80 over there. Then angles on a straight line is 100 degrees. Again, vertically opposite, 100 degrees. Then look here, we had said angles subtended by the same, angles subtended by the diameter on the circumference add up to 90 degrees. And part of it has gone with 40 and 20, that is 60. Remainder 30 degrees. Or we can also get that looking at chord SR subtending an angle 30 here at Q. Chord SR subtending an angle, it also subtends an angle, we still will get 30 degrees over there. So finishing up this side, angles on a straight line add up to 180, and therefore 50 out of 180 is 130 degrees. 130 degrees. Angle sum of a triangle therefore becomes 40, 130 will be 170, out of 180 is 10 degrees. So our diagram is fully filled, and therefore we shall be able to answer all the other questions. Of course, here is also another 90. Yeah. So coming over to the questions, our work is just to give the answers and the reasons. So SRP, angle SRP is 40 degrees. I remember very well we began, that is one of the numbers, that is one of the angles we began with. So there being 40 degrees, reason was angles subtended by the same chord. So same chord on the circumference are always equal, and the chord here, as we agreed, was SP, chord SP. Or we have many answers here. We also considered angles in alternate segments. So we can also say angles in alternate segments. And therefore, angle 40, 40, 40, 40. So they are all equal. Angles in opposite segments are usually equal. Then our angle ORP, come to the diagram. ORP is 20 degrees. ORP is 20. How did we come about? We got 20 by looking at the aspect of here being a radius, there being a radius. We could create an isosceles triangle and the base angles of an isosceles triangle. So base angles of an isosceles triangle are always equal. Base angles of an isosceles triangle are always equal. Or somebody can just say simply angle sum of a triangle add up to 180. Angle sum of a triangle add up to 180 degrees. Still the same thing. So all of them put together were able to give us the angle 20. Then angle RPT. Angle RPT, where is it? RPT is 70 degrees. RPT 30 plus 40 is 70 degrees. What is the reason here? Part of it, 40, we got by angles in opposite segments, alternate segments, or angles in alternate segments. Then 30 we got by angles in angles subtended by the diameter was 90, and already we had 20 and 40. So there being no any other business, we were able to remain with 30. So all this combined, we can say angle sum of a triangle should also add up to 180. Angle sum of a triangle should also add up to 180. Then finally, STP, angle STP, we got 10 degrees. And that was purely angle sum of a triangle, which is usually 180. So guys, this is very simple. I always tell my students, these are the free marks you should go for. Just stating an angle, giving the reason, and that is the same reason that you used in calculating the angle. Then it's very cheap. I'm not sorry to say, very easy. So maths is doable. Let's love this subject. The day you will start passing in maths, I think it will open up your brain and you will not be able to read even. Yes. The rest of the subjects will automatically, you will automatically do well. So guys, thank you again for listening. Thank you for giving me your attention. Follow through, study well the diagram. To the learners, can you employ the ideas of angle properties of a circle? Go to Form 3 again, combine with the aspects of chords, circle chords and tangents, and nothing will be too difficult for you. It will be as easy as A, B, C, D. So at New Yankees again, like I said, I cannot fail to remind you, our main big aim is to help our learners improve their performance in mathematics because this subject is doable. It's doable. My teacher used to say, failing in maths is very difficult, but passing in maths is very easy. So you can reach me on my contacts or through my contacts, 0729685517. You will be able to speak to the Beacon Master. Thank you, and may you be blessed. Subscribe, please, share, and like.